Hello, welcome back. Today we are going to talk about the pooling layer. The pooling layer is often used in 2D datasets, two-dimensional datasets, after the convolutional operation. If you have an image like is similar to this, and we have some cells here, the pooling layer would be operated as this. Firstly, we have the filter that will do two different tasks depending on the type of pooling layer that you choose. We have the average layer and the maximum layer, max pooling layer. How it works, the pooling layer? Firstly, the first cell in our output would be the operation between these cells, the first two cells, and our filter, that now our filter has a dimension of 2 by 2. Okay, and the operation will be, if you choose the average layer, we will do the average of this box, and you will output at the first position in our output matrix. Okay, and if you choose the max pooling layer, you would choose here the maximum value of this cell, and you would output here. So that's how it works, the pooling layer here. However, we have two hyperparameters in the pooling layer. One is the stride. No, three hyperparameters. One is the stride, the second one is the padding, and as we have seen before, is the filter size. That the filter size X and the filter size Y. So we have 4 hyperparameters. What is an hyperparameter and how it differs from a normal parameter? The hyperparameters are values that you cannot optimize, and your neural network cannot train these values, so you have to choose manually. For example, the padding is often chosen a padding of 1 or maybe 2. And what is the padding? Let's explain before. The padding. If you have an image, our filter will start from here. However, if you want to start our filter a little bit more left, we need to create a padding. And what is the padding? The padding creates a padding of new values around our image, and this allows us to move to have our filter here, maybe, instead of starting the filter here. So our padding could also be divided, our hyperparameter padding could also be divided into px and py. So you can choose these numbers, and I have to say that the values that are initialized in the padding are always 0. So this don't mean a really difference between having it or not. What is the stride? The stride is the number of cells that you shift between each operation. For example, if we have this matrix and you have the first filter here, if you define a stride of 1, the filter in the next situation will be one step right, and if you define a stride of 2, our second output will our minor matrix will be moved two columns each one. So I think that the strides are usually set as 1, and the filter size, depending on how you want to compress our image and reduce the size, you can it can depend on you can choose between 3 and maybe 30. So it is a really big range. So I think that's all the theory that we need to implement our pooling layer. So now we need to code it. Now we can start coding the pooling layer. The first thing that we need is to include the eigen library. And the vector, the std, the exception library, and we also need to include our layer library. Our configuration file, and I think we also need to create a file in utils. Called max and average. In max and average we will define the function that we are going to apply in the pooling layer. We know that there are two kinds of function. The first one is the average. I have coded myself the function that finds the maximum in a specific block, and the one that does the average in a block or a minor matrix. So now we can start coding our neural network. So the first thing we need is to create a template in which we will name the activation. Okay. We can define our own matrix that will be dynamic as always, and we will call matrix, and also type def the matrix that is dynamic and uses the scalar instead the scalar the integer value, and it will be called int matrix. Oops. We need to define our hyperparameters in the pooling layer. So the first thing is the number of channel rows, the channel, the number of columns in each channel, the number of channels that go inside, and the pooling filter size of rows, and also the pooling calls, number of calls. We also need to define the number of out rows and the number of out calls. We create our location matrix where we will store the location of the average or the maximum. We are also going to create the set, that is where we will store the output before the activation. MA will be the output after the activation function, and the derivative of the input with respect to the input. Okay, that's. We can start creating our constructor. As you know, we need to define all our variables, constant variables. The first one, the width of our input, the height of our input, the number of channels that we input, the pooling width, and the pooling height. And now we can start initializing them. We create our layer. This would be in the first, as you know, in the first parameter we will create the number of parameters that we will have, the number of outputs of inputs that we will have in each layer. We are also going to define this. You have to take into account that an integer division is always passed to, is always approximated to the lowest value. Right? In height and pooling height multiplied by the input channel. Okay, now we have defined our layer, our layers parameters. The number of rows, 8. Channel calls, width, the channels. We are also going to define the rows. That would be the pooling height, the pooling calls, pooling width, the output rows, and output calls. Okay. That's all. We have initialized our pooling layer. We now need to override the init function that we define in layer. We don't need it now because because we don't have parameters to optimize, so we will let them empty. Okay. We also need to override the forward matrix prep layer data. We need to do that in this video, and we define the getter of the outputs of the function of the layer, sorry. And the function that backpropagation that will need in the output, in the input, the prop layer data, and the matrix next layer data. Okay, that's all. We also need to define the getter of the backpropagation data, backprop data, and the optimizer. But as you know, we don't have any parameter to optimize, so we will let this empty. Optimizer opt. That's all. We can now start coding the feedforward function. We will create the variable in which we will store the number of observations or data calls. Okay. And now we can define the matrix in which we will store the locations of our maximums. Out size number of observations. Nops. Okay. Now we can we need to use mblock to store the address of each pooling block relative to the beginning of the data. So we will define a pointer that will look at mblock.data. We need now our hyperparameters like the stride, that in this case the stride will be given by the number of rows multiplied by the channel number of calls. So our stride will be constant now. The end gap and channel of rows multiplied by the pool number of calls multiplied by the end out calls. And now we also can define the column stride. This is given by a function that I will show you, that is published in the website that I will give you in the link of the video, in the description of the video. Pooling calls. Right. Row end gap. Out rows multiplied by the pool rows. Now we need to loop through our channels, because we may have some channels, as I said, the green, the blue, the red, all these things. Channel start 0, channel start must be less than channel dot end, the stride of our channel depends on this thing, on this variable. So now we can actually define the code end, then where we will finish our loop, that will be in channel start plus cold end gap. Plus equal call straight row end row end gap. And now we can loop through our rows. Now we have loop through our calls. We need to see each row. row start, row start must be less than row end, row start plus equal and pull rows. And we also need to are going to define log data plus plus, because now we can also add one location data that we will store in log data our row start, in order to later see the maximum value. So now that we have defined our location data where start each block or main or matrix, we can use log data instead of mblock. Okay, that's our variable that we will use is set data. It will define the first variable, the first value in our input of the neural network. Prep layer data dot data. Okay, now we have set data and the source. So now we can do our maybe last thing. We are going to loop through, we don't need that. Data must be less than log data, log n, sorry, and log data plus plus set. Now we have store and offset the pointer to log data. We can now call to our internal function sorry, I have forgotten something. We need to include the functions that we have just created. Utils, no, random, no, max average dot age. Okay, that's now we can finish our code. We have our find block max and the average block. Now we only are going to implement the find block max. Offset number of rows and pull number of calls, the channel rows, and our log data. That's all. And to finish, we only have to to sum to log data and offset the offset that we have just before created. Now we only need to apply the activation function, but before we need to initialize the out size and the number of observations. Okay, that's mset and main. We have just finished. Okay, that's all. We need to do the backpropagation, but when we see the theory of backpropagation, we will start coding it, but this is not really complex. We have done most of the tutorial. So thank you for watching it, and see you in the next tutorial.